Are we about to hit a massive wall in the AI revolution? It's not a lack of algorithms or computing power, but something far more basic: electricity. The explosion of AI, especially data centers, is creating an unprecedented demand for power. If our power grids can't keep up, the AI dream could stall. This isn't just a minor inconvenience, it's a potential crisis. The progress of AI will slow down dramatically in countries that can't provide ready access to electricity. We're talking about national AI ambitions being completely derailed. It's a bottleneck that nobody seems to be talking about enough, but the implications are enormous. So what's the real story here? Let's dive in. The scale of the problem is staggering. We used to think of data centers needing 300 megawatts of power. Then it jumped to 1 gigawatt. Now, we're hearing whispers of 3 gigawatts. That's the equivalent of powering a small city. All of this is directly tied to high-voltage transmission. If the grid isn't upgraded, it becomes a massive bottleneck, choking off the potential of AI. Think about it. All those GPUs crunching data, all those algorithms learning and evolving, all dependent on a reliable flow of electrons. Without it, everything grinds to a halt. The situation is so critical that some companies are resorting to building their own independent power supplies just to keep their data centers running. That's expensive, complicated, and frankly, a sign that something is seriously wrong. One company is stepping up to address this challenge head-on: GE Vernova. Spun out of General Electric, they're focused on modernizing how energy is generated, transmitted, and consumed. And a key part of their strategy is centered in India. India has become GE Vernova's second-largest region, boasting strong manufacturing capabilities and expansive engineering and research centers. They're not just serving local needs. They're producing in India to serve customers across the globe: Brazil, the Middle East, Asia-Pacific, and Europe. This is a global problem, and India is playing a crucial role in solving it. The teams in India are contributing to hardware, software, and integrated solutions for high-voltage direct current, HVDC, and other advanced power systems. It's a full value chain, from R&D to production, designing technologies that are deployed worldwide. This isn't just about building things. It's about innovating the future of energy transmission. Some of the most cutting-edge work being done in India is in the realm of software-defined automation. This technology is designed to integrate renewables, secure networks from cyber threats, and enable remote operations. Imagine substations that can intelligently respond to real-time changes in power flow or disruptions. That's the power of software-defined automation. Teams in Noida, Hyderabad, and Bengaluru are collaborating with colleagues in Canada and Europe on embedded software, digitized substations, hardware-in-the-loop testing, and cybersecurity protocols. It's a global effort, with India at the heart of the innovation. This isn't just about making the grid more efficient. It's about making it smarter, more resilient, and more secure. For years, investment has poured into renewable generation, like onshore wind, offshore wind, and solar. But there's been a significant lag in grid investment. We focused on generating green energy, but we didn't pay enough attention to how we were going to get that energy from where it's produced to where it's needed. You need a much larger, more flexible transmission and distribution system because solar and wind power are less predictable than traditional thermal sources. This realization is dawning just as data center growth is surging thanks to AI, and industry after industry is electrifying its processes. It's a perfect storm of demand, and our grids are struggling to keep up. It's not just about having enough electricity. It's about having the infrastructure to deliver it reliably and efficiently. The challenge is immense, but the stakes are even higher. Consider this: AI in the US alone could double electricity consumption in the next decade. And many data centers prefer to stay within national borders for reasons of confidentiality and security. So, countries that can't deliver sufficient electricity will struggle to host large-scale AI systems. In America, there's even talk of building new gas-fired and nuclear generation to feed these data centers. But the grid connection is the tougher part. Some companies have resorted to running independent power supplies before eventually tying into the grid. That's expensive, complicated, and not ideal. We end up with a bottleneck that is primarily about transmission infrastructure. It's a race against time, and the clock is ticking. The irony is that the same technology that drives demand for electricity also holds part of the answer. GE Vernova is embedding AI into its own processes, developing solutions for forecasting solar and wind output, managing distributed energy resources, and stabilizing the grid when renewable output fluctuates. We have to replace systems built over 100 years and perhaps 20 years. So AI helps us automate repetitive engineering tasks, run risk analyses, and improve our software quality testing. As a result, we can speed up how quickly we deliver the grid of the future. It's a virtuous cycle, AI driving demand, but also providing the tools to meet that demand. The key is to embrace these technologies and deploy them rapidly. Building a stable grid also depends on having the right hardware. GE Vernova has a large center of excellence for HVDC systems in India. High-voltage direct current is well suited to transporting electricity over long distances or beneath the sea. If you want to move power from remote wind farms to far-flung regions, HVDC is a key element. Indian engineers are heavily involved in designing those complex controls and hardware setups. This technology is crucial for unlocking the potential of renewable energy and ensuring a reliable power supply across vast distances. It's a vital piece of the puzzle in building the grid of the future. India is moving in the right direction with its investments in infrastructure and emphasis on digitization. Customers are creating sophisticated control rooms that allow remote operation and fault monitoring for hundreds of substations scattered across multiple states. The software behind those control centers is developed in partnership with teams in India who are also rolling out renewable energy management systems. It's a testament to India's commitment to modernizing its power grid and embracing the future of energy. But there's still much work to be done, and the pace needs to accelerate to keep up with the growing demands of AI. The ultimate goal is to build a power network that can endure sudden changes in supply and demand, which renewables inevitably bring. We used to rely on thermal plants that ran at high capacity factors. Renewables can be more intermittent. So, we're introducing new equipment, such as static compensators, as well as robust forecasting systems to manage where the clouds might reduce solar output. It's all interlinked, and digital solutions are crucial for synchronizing that. The future grid is dynamic, intelligent, and resilient, capable of adapting to the ever-changing demands of the 21st century. It's a complex challenge, but one that we must overcome to unlock the full potential of AI. Speaking of innovation, let's shift gears and talk about the entrepreneurs who are driving the AI revolution. In the National Capital Region of India, we're seeing a new breed of AI startups, led not by fresh-faced graduates, but by seasoned industry veterans. These are people with decades of experience at companies like EMC, Dell, NetApp, and HP. They have the vision, the connections, and the ambition to create significant innovations. And they often have the deep pockets to bootstrap and run their ventures. It's a fascinating trend that's challenging the traditional image of the startup founder. These veterans have seen multiple tech disruptions over the past 3 decades, and they may have a unique edge in navigating the current AI landscape. Let's dive into what they are doing. One such startup is CoreOps.ai, founded by Rajesh Jaini and 3 other industry veterans. They're focused on providing AI solutions to enterprises, leveraging their rich experience of leading technology businesses across over 100 countries. Their strength is in the B2B realm, and they have a deep understanding of the industry pain points. They're working on multiple areas, from accelerating CRM for manufacturing customers to improving IT and sales processes for German companies. Their agentic AI approach is cutting modernization time by 50% and costs by 25%. With a strong pipeline of orders and technology partnerships with AWS, NVIDIA, SAP, and Salesforce, CoreOps.ai is poised for rapid growth. It's a great example of how experience and innovation can combine to create something truly special. Another interesting venture is AI on OS, a joint venture between C.P. Gurnani, the former CEO of Tech Mahindra, and InterGlobe, the parent company of Indigo. AI on OS aims to transform businesses by integrating Gen AI technologies, with a particular focus on the travel, transport, logistics, and hospitality sectors. They're leveraging technologies like agentic AI and domain language models, and developing AI tools and accelerators for their clients. With deep domain expertise and a 250-person team, AI on OS is already making waves in the industry. Their recent partnership with Indonesia-based telecom company Indosat Ooredoo Hutchison demonstrates their ambition to expand their reach and impact globally. It's clear that these veteran-led startups are bringing a new level of sophistication and experience to the AI landscape. Let's take a step back and address a fundamental question. What's the key ingredient for becoming truly great in AI? The answer, according to experts, is math. For India to become a leader in AI, it has to up its math and statistics capabilities. Algorithms, at the root of all AI, are nothing but mathematical equations. It's all logic, and the only way to handle vast amounts of data is through math. Data scientists are at the heart of this, creating knowledge from data through quantitative and programming methods. But a data scientist has to be more than just a programmer. They have to be a better statistician than a software programmer, and also a better engineer than a statistician. The data scientist applies mathematics in solving problems through software. Even if you have a pre-built AI model, if something in the environment changes and the accuracy of the model changes, you may have to change the underlying algorithm. And that's not like changing a feature on a phone by programming. It's a bunch of equations. You can't change it without understanding the math. If accuracy has to be 99%, it cannot be done at the code level. You have to dig into the algorithm, understand the basis of the algorithm. That's why institutions like NITK Sarathkal are offering B.Tech programs in computational and data science through the math department, not the CS/IT departments. This approach recognizes the fundamental importance of math in AI and data science. However, most engineering colleges currently produce programmers from CS/IT departments in the name of AI, ML, and data science engineering, thereby diluting the importance of math. This is detrimental to India's ambitions in AI. We need to shift our focus to building a strong foundation in math and statistics if we want to truly excel in this field. It's not enough to just learn how to use AI tools. We need to understand the underlying principles that make them work. Now, let's shift gears to a completely different topic, one that highlights the darker side of technology: the use of technology in espionage and warfare. Reports have emerged that Israel's Mossad agency injected explosives into pagers that exploded across Lebanon and Syria. Hezbollah had reportedly ordered 5,000 pagers from a Taiwan-based firm, and the first batch of 3,000 pagers was laced with nearly 3 grams of explosives each. The pagers were modified to go off when a message was sent. On September 17th, Hezbollah operatives with the pagers received a message, and the pagers exploded. This is a chilling example of how technology can be weaponized and used for deadly purposes. It raises serious ethical questions about the responsibility of technology companies and governments in preventing the misuse of their products and capabilities. Finally, let's touch on a couple of unrelated but important news items. Bengaluru has been battling severe rain and hailstorms, with trees uprooted and cars damaged. And Hamas has unveiled its Mubar-1 homemade air defense system amid the intensifying Israel-Palestine conflict. These events highlight the diverse challenges facing the world today, from climate change to geopolitical instability. It's important to stay informed and aware of these issues, as they can have a significant impact on our lives and the future of our planet. So, what's the takeaway from all of this? The AI revolution is here, but it's facing a critical bottleneck: our power grids. We need to invest in modernizing our infrastructure, embracing technologies like software-defined automation and HVDC, and ensuring that we have a strong foundation in math and statistics. The future of AI depends on it. But the challenges don't stop there. We also need to be mindful of the ethical implications of technology and work to prevent its misuse. From pager bombs to climate change, the world is facing complex challenges that require innovative solutions and responsible leadership. What do you think? Is your country's power grid ready for the AI revolution? Let us know in the comments below. And don't forget to like and subscribe for more in-depth analysis of the latest technology news.